Talking about mole relationships, we are looking at the parametric relationship between mole and other parameters that relates to stoichiometry. Mole and mass, mole and molar mass, mole and volume, mole and number of particles, mole and concentration, and mole and Avogadro's number. These relationships are very vital, as it will be required of us as we try to carry out some manipulations in stoichiometry. So looking at what we have on the screen displayed, mole is related to volume by the formula N equals V over Vm. That is to say, N is equals to volume over molar volume. It is also good to recall that 1 mole of any gas at STP occupies its volume of 22.4 dm cube. Mole is related to mass and molar mass by M over mm, and is related to concentration by the formula CV over 1000. Lastly, is related to number of particles by the formula N equals number of particles over Avogadro's number. These relationships will be used as we try to carry out different calculations under stoichiometry. Away from that, now let us take a look at molar mass. When we talk about molar mass, we make reference to the relative atomic mass of elements or the relative molecular mass of any given molecule. Its unit is usually in gram per mole. Let us take a look at examples of molar mass. We are told to calculate the molar mass of sodium metal and oxygen gas. How is that done? Since we are asked to calculate the molar mass of sodium metal, we recall that the RAM, relative atomic mass for sodium, is 23. Therefore, its relative the molar mass will be 23 gram per mole, because we've been told that molar mass is the relative atomic mass of elements expressed in grams, or the relative molecular mass of any other substance molecules expressed in same grams per mole. Now, talking about the relative molar mass of oxygen, the relative atomic mass of oxygen is 16. Since oxygen is a gas with O2, then it means that its molar mass will be 16 times 2, which is 32 gram per mole. So this is that for oxygen. It is worthy to recall that the molar mass of an element is its relative atomic mass expressed in grams. Let us always remember this at any point in time. So let's take a look at example 2. Our next example, we are told to calculate the molar mass of nitrogen gas, phosphorus, and 2 moles of calcium. To calculate the molar mass of these substances, beginning from nitrogen first, nitrogen is a diatomic element. Its relative atomic mass is 14. So the relative molecular mass of that element will be 14 times 2, which is 28 grams per mole. For phosphorus, the relative atomic mass for phosphorus is 31, so its molar mass will be 31 grams per mole. And the next question says we should calculate the molar mass of 2 moles of calcium. 1 mole of calcium has relative atomic mass of 40. So 2 moles of calcium will be 40 multiplied by 2. And that gives us 80 grams per mole. So the molar mass of 2 moles of calcium is simply 80 grams per mole. So this is how to calculate molar mass of any given element or compounds. Now let us take a look at more examples that had to do with the molar mass of some compounds. We are asked to calculate the molar mass of the following compounds: sodium carbonate, ammonium chloride, calcium carbonate, and zinc sulfate. and in parentheses we have been given their relative atomic masses. Sodium is 23, carbon is 12, oxygen is 16, nitrogen is 14, hydrogen is 1, chlorine is 35.5. We are not expected to round it up. Calcium is 40, carbon we've seen it is 12, oxygen is common 16, zinc is 65, sulfur is 32, and oxygen is 16. So these are all the relative atomic masses of these individual elements provided in the brackets. So how do we go about calculating the molar mass of each of these compounds? To do so, we simply have to sum up their individual atomic masses. And summing up the atomic masses will put to cognizance elements that are appearing twice, 3 times, or even more. So put that into cognizance, and we are going to multiply their relative atomic masses by the number of times they are appearing in that compound, so to say. So let us take a look at how to solve the questions above. It is worthy to note that the molar mass of compounds is simply its relative molecular mass expressed in grams, as has been said before. So for sodium carbonate or sodium triazo carbonate 4, the molar mass of the compound will be, since sodium is 23 and there are 2 atoms of sodium in that compound, it's going to be 23 times 2 plus carbon is 12. So we're going to add the RAM for carbon, relative atomic mass for carbon, plus the relative atomic mass for oxygen is 16, but there are 3 oxygen atoms there, so it's going to be 16 times 3. And by the time we carry out that calculation, we have 106 grams per mole for sodium carbonate. For ammonium chloride, which is NH4Cl, the relative atomic mass for nitrogen is 14. The relative atomic mass for hydrogen is 1, but there are 4 hydrogen atoms in that compound. So for that, it's going to be 1 times 4. And then we have 1 chlorine atom, and the relative atomic mass for chlorine is 35.5. So by the time we sum that calculation up, we're going to get 53.5 grams per mole. The next compound is calcium carbonate. Calcium carbonate has calcium, carbon, and oxygen. Calcium is 40, carbon is 12, and oxygen is 16. But there are 3 atoms of oxygen there, so we have to multiply the 3 by the relative atomic mass of oxygen, and that gives us 48 plus 12 plus 40. So summing up, we have it as 100 grams per mole. And lastly, we have zinc sulfate. The same way, all the individual relative atomic masses of the elements are being summed up, but in the case of oxygen, it is multiplied by 4 because there are 4 atoms of oxygen there. And when we do that, we're going to have the final answer given to us as 161 grams per mole. So this is simply how to calculate the molar mass of any element, molecule, or compounds. So, dear students, you have to go ahead solving the following questions. You're asked to calculate the molar mass of the following compounds as displayed. Their relative atomic masses are provided. So just as we have seen, you ought to sum them up, taking into cognizance elements that are having 2 or 3 atoms in them. So take note of that and proceed. You can send your answers to us, as we shall be waiting to receive them as due.